Welcome to our lesson on the life cycle of a star. Same as normal, could you please complete the do now questions and then, pause the video, complete the do now questions and then unpause and check your answers. Okay, enter your answers onto your notebook. Okay, so the first question, name the planets of the solar system in order, starting with the closest to the sun. So we've got Mercury, Venus, Earth, Mars, okay, Jupiter, Saturn, Neptune, and Uranus. Okay, capital letters because they are names. What is a terrestrial planet? A terrestrial planet is a planet that's made up from rocks, okay, so solid materials. So we're going to say a rocky planet. Okay, and then what is a gas giant? It's a planet made from gases. Okay, what keeps planets in orbit around the sun? Obviously that's going to be gravity. So it's important to remember that the Earth is falling towards the sun, but fortunately it's going fast enough that it keeps missing it. Okay, so it stays at the same distance from the sun. Okay, and what is a light year? A light year is simply the distance light travels in 1 year. Okay, make sure you get those answers in your notebook. Okay, so do now, in other words, our learning objective today is describe the life cycle of a main sequence star. We will be constructing an answer for a qualitative extended response exam question in the correct format. Okay, and unfortunately, because we're not in lesson, we can't evaluate our peers' work against a mark scheme, so you'll be looking at your own answers. Okay, so why are we doing this? Because in exams, you need to be able to communicate what you understand, okay? In real life as well, you need to communicate what you understand. Right, so our big question today is describe the life cycle of a main sequence star with a mass much larger than our sun. Amazingly, despite our sun being over 100 times the diameter of the Earth, it's actually a really, really small star, okay? But that works out to be really quite good for us. So, stars are formed from clouds of gas that contract under gravity, okay? We call that cloud of gas a nebula. Okay, early stars were formed from just hydrogen. Okay, that is the most abundant gas in the universe. You're going to need to know the stages of the different parts of the star, okay, for its life cycle. You also need to know that the forces are balanced acting on the stars. We found out in Newton's law, when we have balanced forces, things stay still. Okay, there's no change. Okay, when we have a ball of gas that's contracted under gravity, the gravitational forces are acting inwards. Okay, there's a gas pressure that pushes outwards. Okay, that gas pressure is because the gas gets very, very hot. When it undergoes nuclear fusion, it gets extremely hot and pushes out, and that's what keeps the star the same size. Okay, so you have got this in your notebook. You're going to be filling this in. Okay, I will try and fill it in with you. Okay, so let's look at what we need to know. There's a lovely diagram here that you can come back to that shows you the main stages of the star. Okay, so all hydrogen was made in the Big Bang. Hydrogen is fused together to form helium in the main stage of stars. Okay, helium up to iron is formed in the red giant stage. Okay, so we'll find out a bit about that in a second. Elements heavier than iron are formed in supernovas. Okay, so anything with a mass greater than iron, so it comes after iron on the periodic table, they had to be formed in a supernova, and we need to find out what one of those is. Okay, so the clouds of gas and dust, which is the nebula, gather due to gravity, okay, and a protostar is formed, okay, that's a baby star, okay, it's when the star starts getting warm, Okay, it starts generating heat because the particles are smashing into each other so quickly and so frequently. Okay, they change into stars like our sun when they start fusing hydrogen to form helium. Okay, and that's when it's a main sequence star. When the star runs out of hydrogen fuel, it cools down and swirls out, becoming a red giant. Okay. When there are no more light elements to use, it collapses and becomes a white dwarf. Okay, and it's white because it's still giving out heat. It's no longer red because it's not as hot. Okay, and that will eventually cool to become a black dwarf. Okay, if it's a high mass star, so we're looking at over 1.5 times the mass of the sun, when it runs out of hydrogen, it cools and swells to form a red supergiant. Okay. A huge explosion then takes place after the red supergiant stage. Okay, when it's run out of light elements, and a supernova occurs. Okay, so that's going to shed a huge amount of material into space, okay, and that will eventually form planetary nebula. A planetary nebula is what forms planets, okay, so it'll be all the rocks or the gases that are thrown out from a supernova, and then they will gather under gravity to form a solar system, okay. Right, so after the supernova, the core crushes basically to become a neutron star, which is extremely dense. Okay, if there's enough mass, okay, that neutron star will continue collapsing until it becomes a black hole, okay, which is extremely dense, even more dense than a neutron star. Okay, we have this now, and you are going to fill this in, okay. So what do we need to type in here? Okay, a protostar formed from a cloud of gas. We're going to put in brackets a nebula. Okay. The gas starts okay. Okay, so the next part we're going to have, goodness me, the red giant. No, it's a main sequence. Okay. Okay, this is where hydrogen Okay, so we need to fill in the rest of those boxes. Okay, I'm sure you'll be able to do that from the information in the video. So that's just a bit of modelling of how to fill those bits in. Go back and use the video and complete the rest of the boxes. Okay, so we've got red giant, white dwarf, black dwarf. Okay, so that's for a star similar in size to our sun. Okay, that's on their first slide about the stars. Red supergiant, supernova, neutron star, black hole. Okay, if you need any help with that, just pop it in the comment section underneath the assignment. Okay, so we've done the first two boxes together. You've got to do the rest of it down there. Okay. All right, so a bit of a hinge question for you. Let's find out what you understand from this. So you just need to use the drawing tool and link up those boxes. Press pause while you do that. Okay, so let's have a look at what we need to write in here. So let's look at the different parts. Okay, so we've got main sequence, black hole, supernova, red supergiant. Okay, so the block diagram shows the life cycle of a star much larger than our sun. Draw lines from the names on the left to the correct box on the right and put them in order. Okay, so the first stage is going to be a main sequence. Okay. After this, the second stage is a red supergiant. Then we have a supernova, and then we have a black hole. Okay, so quite simply, we're just looking at our flow diagram to work out what bit goes where. Okay, so now we're moving on to answering our 6-mark question, okay? You'll notice on your notebook there are some core knowledge questions that I'd like you to answer as well. They're obviously the most important parts of the information that you need to use to help you answer all your possible GCSE questions, okay? So we've looked at these before when we've looked at other 6-mark questions, okay? We're looking at what the topic is and the key words, the command word and how it affects what you write, the core knowledge you need to use, okay? That's the bit we've learned in the lesson already. It's on your flow diagram, and how can you start your answer, okay? And that's just a way of thinking about, like, in your exam, what are you going to write to fill up the blank space, okay? So we've got an example from waves, which you would have used last year in year 10. Okay, so what's the topic asked about? Let's look at the question, okay? It says compare radio waves and gamma rays, so it's about the electromagnetic spectrum, it's about wavelength and frequency, okay? What's the command word? Well, it says compare, okay? So we know compare, you've got to describe similarities and differences between things, not just write about one, okay? What's the core knowledge? Well, we've got loads of core knowledge here, okay? I'm not going to go through it all with you, all right? And then how can you start your answer? Okay, sorry, because it's a compare question, we can say about what both things have or what one has compared to the other. Okay. So our question for the we do, okay, describe the life cycle of a main sequence star similar to our sun. What I'm going to do is model how to answer this bit for you, okay? So I'll have the information that you can type into your notebook, and then you are going to write an answer, and then you're going to go on to answer a second question, okay? So very quickly, this is what you're going to fill in. Okay, what's the topic asking about? Okay, so it's asking you about stars, our keywords, gravity, gas pressure, nebula, protostar, main sequence, red giant, white dwarf, black hole. Okay, black dwarf, sorry, not black hole. It's not a black hole because it's similar to our sun. Okay, it's not much larger than our sun. So it's a black dwarf, not a black hole. What's the command word? Okay, it's describe. So we've just got to say what happens in order, basically. Okay, we need to be as accurate as possible. Okay, next, what's your knowledge? Well, we've got all of this in our flow diagram, okay? So if you haven't completed your flow diagram, that's pretty much going to complete it, okay? How can I start my answer? Okay, a star forms from, or gravity causes, okay, so a star forms from a nebula, which is a cloud of gas, okay, or gravity causes a cloud of gas to collapse, okay? You start getting warm, form a protostar, okay? Right, so here's some examples of answers written by previous classes. So you can use those to help you. Don't just copy them because it won't help you with your thing. Okay, and there's your scheme. Okay, right. So what I'd like you to do now is describe the life cycle of a main sequence star much larger than our sun. Okay, so complete the boxes as you've just done. Okay, on your notebook, and write a full answer. Okay, if you'd like something extra to do because you've finished, there's a bit more for you, okay? Right. Thank you very much. Good luck. If you need any help or support, please write to your teacher in the comments box. Thank you very much.